morning, everybody. Welcome to our Science Park and this Marie Curie Auditorium. It's a real special pleasure today to meet all the people, all of you, and particularly some kind of really relevant people here, scientific, from the scientific and the human point of view. You are now in the Science Park. The Science Park is also an experiment between the scientific research institutes and also the new companies based in the knowledge and new companies based in the transfer of knowledge and the development these such activities in relation with the science. So the first floor after the talk, to thanks you presence, is for our Vice Rector of Innovation, María Dolores Real, to introduce the day. Okay, thank you very much.
Thank you. Good morning. Let me to introduce the members of the table, just from right to left. Eugenio Coronado, you know, is the director of the Institute of Molecular Sciences. Afterwards is Ben Feringa, Nobel Prize of Chemistry 2016. Jean-Marie Lehn, Nobel Prize of Chemistry 1987. And Serge Haroche, Nobel Prize of Physics 2012. Well, good morning. On behalf of the Rector of the University of Valencia, Professor Mavi Mestre, and myself, I warmly welcome you all to the Science Park of the University of Valencia. And it is indeed a great honor and a privilege to sit here with all you three this morning. And we sincerely thank you for your presence and for your commitment to the dissemination of science and sharing of experiences in this colloquium with our young scientists. I would like to express our gratitude to Jaume Primer Prize organizers, especially to Javier Quesada and all the team, for giving us this excellent opportunity to discuss and learn about science. And also particular thanks to our young scientists participating in this session, of which we are really proud. Just a few words about our university that perhaps you have already heard before. The University of Valencia is one of the oldest universities in Europe, with more than 5 centuries of history, and one of the Spanish leading academic institutions. It has become a modern university open to the world, an institution of international reference that connects tradition and modernity, science and knowledge, culture and society. The University of Valencia is the biggest of the 5 public universities in the Valencian community. It has the widest offer of studies and research in all major branches of knowledge, from basic and experimental sciences to social sciences and humanities. We have around 60,000 students per year, of which more than 15% of them are international undergraduate or postgraduate students. And we have more than 3,300 professors, lecturers, and researchers, with the support of over 2,000 technical and administrative staff. Besides some buildings and facilities in the heart of the Valencia town, such as the historic building called La Nau, that means the boat that houses now the historical library, the Cervero Palace, the Rectorate, the Botanical Garden, and others, the University of Valencia has 3 main campuses, 2 urban in the city of Valencia, and the third, where we are now, the campus of Burjasot Paterna, that houses the faculties of pure sciences, biology, chemistry, mathematics, and physics, and also pharmacy and the School of Engineering, as well as the core research facilities of the University of Valencia and the Science Park. The Science Park of the University of Valencia is an ecosystem of innovation that celebrates its 10th anniversary this year. It has two complementary and differentiated areas. The business area, that is an outstanding environment for the generation, development, and strengthening of innovative companies based on knowledge and innovation. And the scientific and academic area, that is space for knowledge generation that consists of 7 out of the 23 research institutes of our university, including 2 excellence institutes. One distinguished as Severo Ochoa, the Institute of Corpuscular Physics, and the other honored by the Maria de Maeztu, the Institute of Molecular Science, both ministerial recognitions for research excellence. In this context, we are proud of the scientific activity of the research groups of these institutes that have a recognized prestige at international level. The University of Valencia is among the first in Europe of both incoming and outgoing Erasmus students. We have around 2,500 underdegree incoming students from international mobility programs and almost 2,000 underdegree students from our university in other universities around the world. And with more than 1,000 collaboration agreements with universities all around the world, the University of Valencia promotes teaching and research in international networks with prestigious universities. We are regularly positioned the 3rd to the 5th Spanish university in the rankings of scientific productivity, and according to the last Shanghai ranking, is the best university in Spain in 10 subjects, such as remote sensing, energy engineering and business, food science technology, agriculture, tourism, etc. And internationally, it is the 2nd in inorganic and nuclear chemistry, the 8th in physics, particles and fields, etc. One of the university's main objectives is to maintain its high quality of both teaching and research. But the University of Valencia is much more than an education and research institute. And we are committed to promote innovation and transfer of knowledge, democratic and ethical values, international cooperation and solidarity, and also generation and diffusion of culture and science. Let me conclude by once again thanking you for coming to the Science Park of the University of Valencia, and I'm fully confident that we will have an exciting and fruitful colloquium, an opportunity to reflect on science and the challenges ahead. Many thanks for your attention.
Okay.
Now I will give the floor to Eugenio.
Okay, thank you very much.
Then thank you very much, Loles, for this introduction to our university, and also for the welcome that we have had in the Scientific Park. Well, we commemorate this year the 10th anniversary of the Scientific Park, and that's why it's important to have a discussion about how science is evolving in the last years, and how science now is connected also with the society that is giving, that is financing the research, and also is taking care of what we are doing in research. We are not disconnected, and the Scientific Park is the way in which we can see this kind of situation. Then, today, as previous years also, what we are going to have is a kind of colloquium in which we will discuss about the evolution of science. Science is evolving very rapidly, and then science is having fast changes, and then, well, there are some grand challenges in science. For example, well, there is a challenge about the brain. There is a challenge also about the quantum computation, that we have here people that are experts on this topic. And there are challenges also about the genome, for example, where there are several challenges that are important. And then this interest in science is changing. Then the what is important, but also the how. And the how is one thing that we can discuss also today, that is how the research is changing with respect to previous or past years. Then now we are having these challenges that involve multidisciplinarity. Then we need multidisciplinary groups. Then we should discuss about what we need now. Is we need individual groups formed by one person, or we need multidisciplinary groups? How these kind of things are changing now in the research. The other topic that is important also is to study how is changing at this moment our vision of the spread the science with publications, with meetings, with outreach. In particular, the publications topic is an important topic because, well, there are many concerns in science that now, well, we are going very fast, and we are also trying to publish many fast. There are open access journals, there are not open access. Well, there are many problems that are in science now, and also many solutions perhaps, and we can discuss about this topic. And also, you see, in science we have also the ethics in science is also changing with this fast development, and the presence of other countries. For example, the presence of China in research is changing also the panorama in science, I think, at this moment. Then, well, there are some topics that we can discuss, and then the objective today is to try to discuss about these topics with all of you. Then what we can try to do is to put some questions related with this future of science from the present of science. And then, well, that we can do that is, well, you can try to put questions, or if we want, first we can give the word of our three invited researchers that can give their opinions about this kind of situation at this moment in science. Then perhaps, well, you can first give your comments. First, Serge can give a comment about these topics, and then we can start the discussion with the public.
Yes, so thank you to have invited me. I'm very glad to be here and to have an opportunity to talk to students of this great university. The topics we are going to discuss are very broad, and it's very difficult to know how to start.
No, we can have some concrete.
Yeah.
Well, we don't need to discuss all science today in 1 hour and a half.
So I understood that one of the issues will be the future of science. How do we see the evolution of science in the future? What would be the great breakthrough and so on? And I think in this respect we have to be very careful. If we had asked this question 1 century ago, and in fact some people asked themselves this question at the beginning of the 20th century, the answers would have been very strange. Nobody would have predicted the advent of the computer, the advent of the cell phone, the advent of magnetic resonance imaging, the advent of the laser. All these things have happened some very often in an unexpected way after basic science has given the clues. So I suspect that in the future it will be the same. We have a tendency now to make a lot of predictions. I think this is due also to the fact that science has become very much and very closely related, and I think too much related to public relation and to advertisement. We are, due to the development of science, the fact that we need to get funding, we are obliged to make some kind of promises to say what will happen in the future, and to boast ourselves of things that we are not sure at all. And I think a century ago, the scientists were wiser. They did not try to do that. Neither Bohr nor Einstein nor Schrödinger claimed that what they were doing was going to change the world, and it has changed the world. And I think we have to reflect on that, and we have also to reflect on the way we are obliged to deliver and to pretend that we are going to do great things, even if we are not sure about that. I will conclude by my own field. You mentioned the topic of quantum computing, and I'm working in this field indeed, and the experiments I am doing are aimed at manipulating single quantum systems, single atoms, single photons, and we do really fascinating things with that. We are able to observe the laws of quantum physics, the strange laws of quantum physics as they develop, as they evolve, and we are able to control these systems. And of course, if we were able to do that at the grand scale with huge number of particles, then we would have this fantastic machine which is called a quantum computer. But there are very, very great difficulties to get there. There are a lot of problems to solve that we don't know how to solve today. So I will never pretend that we'll have a quantum computer tomorrow. I must only say that we are enjoying what we are doing, playing with the system, and one thing I'm sure of is that something will happen, that this knowledge will lead to interesting innovation, interesting discoveries, but very probably, most certainly, this application will be a surprise and will be different from what we believe today. And this is what happened in the past, and I think it will happen in the future, and this is what makes science so fascinating, because we cannot predict what will happen. To make discoveries is by definition to go into the unknown, and when we are asked to predict what will happen, we are asked to take up a way of thinking which is contrary to what science is about. So I think we have to reflect about that, and this leads to discussions which have to do with many of the points which have been put forward before. What science is, but also what are the conditions under which we perform science, and what should be done if we want to improve these conditions and not to go in a future in which we are asked to accelerate, to promote ourselves and to work in a global world which has good sides, but which has also some bad consequences. So I will stop at this point. Thank you.
Okay. Then Jean-Marie.
First of all, thank you to invite me here. I'm back here. I know the place. It's an excellent place. It's true. It's true. It's not just because I know you very well, Eugenio, but I think it is indeed a very excellent place. Now, what I would say also is that these people in front here are not the only ones who should be here. We were distinguished by our colleagues. That's why we are now in the conditions which we are. But there are many people around the world who did not get the Nobel Prize and should have gotten it, who are worth it. That's number one. And I remember one thing, that Mendeleev, who was one of the most important chemists, if not the most important, never got it. And when Ben and Fraser Stoddart and Jean-Pierre Sauvage were together in Strasbourg a little bit more than a year ago, they asked me to introduce them. And okay, so I presented some Nobel Prize winners and so on, all the ones which have passed through Strasbourg, especially in the German times, before the First World War, between the Franco-Prussian War, 1870, and the First World War. And so I have about 18 of them. But then I concluded, if you, the audience, are not part of these people called the Nobel Prize winners, don't worry, because Mendeleev never got it. So let's do good science, and okay, if we are selected, we are happy about it. Huh? You have too much to do. I have learned how to say no. So, in fact, you know, Ben, I wanted to tell you one thing. The necessity of bringing them, we have a mission, which is also to bring science to the society. And it's unbelievable how little science is in society. And Ben, I have not finished yet, but I would like you to tell right now that story which you told me about in the taxi when you came here. Go ahead.
Okay, I was at a meeting in The Hague, you know, that is like going to Paris to the government or to Madrid to the government to talk with high government officials who make the programs for innovation in the country. And we had a 2-hour meeting, and afterwards we had a drink or a cup of tea. And they asked me, oh, you got an invitation from Stockholm. Tell us, we heard something in the newspaper about machines or so. And I said, yes, we build molecular machines and molecular nanotechnology. Like, you know, you can move your muscle, or we can talk, you know, your body is full of tiny machines. Yeah, the molecules that make that possible. And they said, are there molecules in my body?
It's incredible, huh?
And so I was so shocked that these are high officials that make things in the countries happen.
Even polymers.
I was so shocked. I wanted to say, Shakespeare is a Barcelona soccer player. But, this is the level of understanding. But I kept very quiet, and I tried to be polite. But I should have said that. But okay, sometimes that we have all together here, all the young people, we have a message to bring out to society, because the level of understanding is sometimes Shakespeare versus a Barcelona soccer player. Sorry to say something.
So maybe I continue a little bit. First of all, I think Serge has given you a good example. I think the fact that science discovers things which we would not have thought about, and I think quantum physics is one of the major progresses there. I'm a chemist, but I think quantum physics changed the world and changed the way you look at it. But because these are things beyond our own reality, we cannot imagine it, and this is absolutely incredible. So I think science has many more things like that to bring to us. Probably will be more and more difficult for people to understand it. Same for me. The distance gets bigger and bigger, but nevertheless it gives us a power. And for instance, one of the most fantastic things which happened recently is the discovery of gravitational waves. The precision of that instrument is something I'm not sure, I'm not even convinced of it, so to say, because that thing was measuring a difference in size of less than a nucleus, of less than a proton.
Much less.
Much less than a proton. You can imagine this?
In fact, 1 billionth of the size of one atom. So if you take your size, about 1 billion times smaller it's one atom, and 1 billion times smaller is a kind of distance change that the antenna was able to.
You see that? I'm not ready to believe it, I would say. But science is not believing, so I accept it. Sure, science has nothing to do with believing. Science is science. And so there is also something which is important for us, and there was a French philosopher who once said that, he said about life, but I think one can say it about science. One thing to do when you are a scientist is to prepare yourself for the unpredictable. Not the unpredicted, for the unpredictable. You just have to be open, because there are things you don't even realize. That's a question of quantum physics again. It's not only unpredicted, it's unpredictable before you do it. I think this is my main point right now. I have some other points, but for later on.
Okay, Ben.
Okay, thank you very much. It's a great honor and a pleasure to be here in beautiful Valencia and at this famous university, where I have also friends and quite a few contacts. It's always a delight to be here. Let me first, I have some remarks I wanted to make besides the story I told you, because don't make the mistake, there are also politicians and also people in government that really understand why science and education is so important and why it shapes our future. So I'm really happy with that. I'm here at the university, and I want to start with making a remark that sometimes people forget, and that is we are here to train the next generation of students, all the young talents I see here. And it struck me that sometimes I get this remark, but we have to think about the next 3-4 years. It's a lot about short term, but if we train you, the students, for tomorrow, or today or tomorrow, we are not doing a good job. What we should do, of course, is train you for 10 years from now. because in 10, 15 years, the young people here will run our companies, run our society. So we have to prepare you for do that by looking across far beyond our current frontiers. And that brings a lot of uncertainty, yeah, that Professor Lehn was alluding to. The way to think forward, and of course science comes with uncertainty. We have to learn, and sometimes we make discoveries that might change the world, indeed. Let me take this example. It was mentioned about lasers and electronics. Smartphones. My students cannot believe, lots of them, that there was a world without smartphones. We have them only 12 years.
It's a smartphone.
And it has completely, okay, he is not a student anymore. He has completely changed our society, no? In the last 10 years. And the liquid crystal displays and the transistors were discovered in the 40s and 50s by chemists and physics, etc., of the past century. And nobody had invented the word smartphone. Nobody had any idea that we would ever have smartphone. I think the first computer was built by IBM at that time. It took 50 years before all these different disciplines, engineers talking about multidisciplinarity, we could build something like a smartphone and it changed the world. So never forget, I think that the university should follow their message. That is, trying to advocate and to work on knowledge and fundamental science. That's our main goal. And then of course we are not disintegrated from society. We should work together with our people in society, with our governments, with our industry. That's why we are at the science park here. There are tremendous opportunities for new entrepreneurship, etc. But I think the role of the university, I cannot advocate that enough, is not a business. We are not a company. We are meant to educate, to train, and to invent, and discover, and to learn. And I think sometimes people forget that a little bit in this modern society. And so, yes, there are many things to say about what will be the next phases. You know, it's also it's difficult to predict, of course. That's why we are at universities, to invent our future. Let me stop with that at the moment, you know, because I'm sure there are many questions.
Okay, then. Thank you very much to all of you for this starting point for the discussion. Then now, what we can have is questions from the attendants. From the students, from the professors, from the doctorates. Then, who is the first to put a question? Yeah?
Maybe I have a small question.
Yeah, you can. The microphone there.
I have a small question about the artificial intelligence. I don't know how it's happened in physics, but in chemistry, I read a lot of papers that the artificial intelligence actually is more important in chemistry. But what left for us? I mean, the AI could take care of our lab work, could design the molecules. So what's left for these students?
What could be done?
What?
The artificial intelligence could, I mean, they could do the synthesis, they could design the molecules, the materials, so what's left for us?
First, what is intelligence? I think rather than artificial intelligence, better to have natural intelligence. Huh?
Yeah.
The brain is still the best computer.
Mm.
Of course, the computers, they do things which are very dedicated, extremely efficiently. But we are still very far from knowing how the brain functions, which is the most fantastic machine for me which exists in our universe.
Yeah.
I say really, I mean it, in the universe, because the brain has allowed us to ask questions about the universe which has created us. We are a result of the universe, of evolution in the universe, of self-organization of visible matter. And the brain has allowed us to understand that. The brain has led to quantum physics. Of course, quantum physics exists independent of the brain, but without the brain you wouldn't have it. So I think, I don't think it will be, okay, maybe it will be molecules, I have no idea. But our brain is made with molecules, there's no doubt.
Yeah.
So this complexity of molecules has generated something.
We have molecules in our brain?
You are a physicist, I know. You don't know what a molecule is. But yes, it happens that we have molecules in our brain.
No, we have even metal oxides also.
Metal oxides, yeah, a little bit, but not too many of those.
Well, not so many, but there are metal oxides also, not only
I
one.
once shocked very much a person in a sort of a public session. This is not a public session, they're all scientists here. And there was a lady asking questions about molecules and so on, and she didn't like there to be molecules. Said, you are a bunch of molecules. And then there was silence. So I think, okay, let's get back to your question. Artificial intelligence, yeah, sure, it will develop very well, and if quantum computation comes along, this is absolutely fantastic, and we cannot really see how far this will bring us. Probably things we cannot predict right now, we don't know about. But nevertheless, this will be done by what comes from our brain. So we have also to understand that. There are now people doing fantastic things with the brain. It's not my field, but I talked with some of them. For instance, Suzumu Tonegawa, who got a Nobel Prize in biomedicine and physiology, and the same year I got the chemistry. He has been working, I discussed with him because he has become a neuroscientist. And you can, by this thing called optogenetics, you can induce a mouse to think that it was in a place where it has never been, creating false memories. So that also is an ethical question. If you are at a trial and you are testimony, how do you know what you say is true? You may be convinced it's true, but it was not true maybe. This is a complicated thing. Of course, it's probably a very small percentage of these cases, but the case exists that you can have wrong memories, that you were thinking of something which has never happened. That shocked me, I must say.
Thank you very much.
Then, more questions, yeah?
Actually, I did my master degrees in the field of, I think
It's working.
Okay.
It's working.
No, it's working.
Okay. In the field of physical, quantum physics. So, and I asked, where is the application? And I heard about the quantum computer or the smartphone or the SIM quantum. So I don't know how does they will work. I think we will get a quantum future, or this is my question. Application of the quantum.
Yeah. First of all, I think that all the instruments that we have in our daily life today are quantum objects. They are based on the laws of quantum physics, on the laws of optics, the way atoms interact with light, which is based on quantum laws, or the way electrons circulate in metals and semiconductors is also obeying to quantum laws. So all the objects, all the instruments that we have today in our life are already quantum. But when one talks now about a second quantum revolution, what one wants to do is to use the strange laws of quantum physics directly to achieve tasks which are not possible with the objects that we have now. And this is because quantum systems are very fragile. The quantumness is very easily destroyed by the interaction with the environment. This is called the phenomenon of decoherence. So what we try to achieve is to put quantum system in such a situation that they keep exhibiting the quantum effects and by being protected against decoherence. And this is the difficult part. One aspect is, of course, the quantum computers. It is a big dream that if you are able to make a huge number of quantum systems interacting with each other, completely protected from the environment, you will be able to compute in ways which are much more efficient than classical machine can do. But we are still very, very far from that, and I'm not even sure this will happen. But beyond that, there are other things you can do. You can build, for instance, quantum simulators. A quantum simulator is a rather small ensemble of atoms, let's say about up to 100 atoms, that you put in a lattice using lasers to build an optical lattice, and you make a copy of a real system, but at quite different scale. In real condensed matter physics, the atoms are separated by about 1 angstrom, a few angstroms, whereas in this system they are separated by 1 micron or a few microns, so they're much more dilute, which means that the interactions are much weaker and that you need to go to much lower temperatures, but the laws of physics are the same, and on these emulators you can learn how real systems behave, and as soon as you have more than a few tens of particles, no classical computer can solve the Schrödinger equation because the space of solution is too huge. So you can just, by watching the system, learn how this small ensemble of atoms behave. And for instance, even in chemistry, you could maybe synthesize new molecules just by playing with the system. I like to think about this as a kind of quantum chess game. You have, on a chess game, you have 64 places, and you have a few different kind of pawns, and you can play, you can change the rules, you can change the way these pawns interact with each other, and this is a quantum game, which means that the pawns can follow several passes at the same time. So it's much more complex than a chess game because you have superposition of possible solutions, and this makes the game impossible to deal with a classical computer. You all know that artificial intelligence has made machines able to beat any chess champion, but it is a classical chess game. In a quantum chess game, no machine for the time being can understand what will happen, and so you can use these systems, this ensemble of atoms on a lattice, to simulate situations which might lead to some surprises. In fact, all the game of quantum computing started that way. In 1982, Richard Feynman made this remark. He said, nature is quantum, so if we want to understand how quantum physics work, we have to build some quantum machines and look at how they behave. And this is exactly what we are doing. And this is much easier than the true quantum computer, which will involve billions of atoms. Here we can work only with 100 particles, and we learn a lot of interesting things. So that's one of the new possibilities of the quantum. And of course, it is not something that will be marketable tomorrow. You will not have this small quantum chess game that you can buy in a store and work at home, because it involves a lot of physics. You need cold atoms, you need really to work in a laboratory to do that, but it's a very interesting thing. I think I will stop here, but there are other quantum system which will be interesting in the future. Quantum communication and also quantum sensors, small system which will be sensitive to perturbation, to electric and magnetic fields, much more sensitive than the one we have now.
It's nice to be here. We learn a lot of things. Huh?
More questions? Do you have? Yeah?
I'm sure I'm, as many other people, been shocked by this story about politicians not recognizing they have molecules in their bodies. But I guess my question is, what can we do as a scientist to improve the situation? So people who are actually making decisions about the funding science we are doing, actually doing it, making those decisions, understanding what they actually, where the monies are going.
It's an uphill battle. Le tonneau des Danaïdes, you know that, the barrel of the Danaïde. Everything, you cannot fill it up, it's impossible. Pour les travaux d'Hercule, Hercules works. It's something very, very difficult. And for me, I sometimes see people, look, you are ready, you are prepared to play 3 hours of tennis a week to learn how to play. But you spend less than 15 minutes, you spend no minute doing any science. How can you, how do you want to make people understand what is happening, what science is? The media have a big problem there, because the media has spread mostly low-grade news, if not fake news. They have a fantastic responsibility. You all can go around, and you should go around the city and try to, when you walk around, you're in a supermarket, you talk with the person next to you, and do you know what you have been buying here? You have bought molecules, huh? You have molecules in your thing. maybe they can, I don't know, everybody, all the scientists can contribute, and we are just 3 here. You are many more, and this is something I have to do. I have no answer to that, except that it's getting more and more difficult, probably. Also because of the fake news.
Do you do this? Do you talk to the people in the supermarket?
Not supermarkets, but in science museums and so on, and general public lectures, yes. And maybe, could be, yeah, that's a good point, maybe I should try next time. No, sure, one should do it. Of course, you have to find a reason to start that. But if you look, if somebody looks at a bottle and looks at, you know, that people look at the composition of what they buy. You can ask them, okay, what do you think about what is in there? Something. That's a good point. Yeah, do it. Should do that.
This is of course a really important point for all of us at the universities and schools and whatever, to go out for outreach. I saw that you have this beautiful science event here where you get public involved and so at the university, school kids. I also go to schools a lot. I think there we should start, elementary schools, high schools, etc., to train or to teach, to inform the students, but also the teachers, because also some teachers are don't feel very comfortable with this, you know. And so, and then public events, where you can give the message, you realize what is your smartphone made of, yeah? What is your soap? You know, that you wash your hair in the morning or you take a shower. What is your food? What is your plastic? What is your clothes, your car? All these things, the awareness to confront people, you know, with what is daily life and what brought us all these things that makes a modern society. And what are the real problems? We don't have to deny that there is a problem with all this plastic waste, but that brings us, of course, to a new challenge also for us. How are we going to recycle materials and reuse materials? So I think you should not defend yourself, but inform people and talk about facts and not about opinions, because there's so much nonsense on the web and people believe things, etc. And I think it's our task and our duty to properly inform the people and start at young age, start with the children.
Yeah. Then microphone there.
So you, of course you're right, science is on the one hand, by the way, thank you for your introduction, a very beautiful thing and very important. But if you consider now the life of the scientists here, the younger ones, actually I think it's quite hard to make a stand in science as a young scientist to, you know, go through the system. And I would like to hear your opinion about this academic system, how it works, if it's improvable in some way, if it will stay the same over the next decades or whatever, or if you could comment on that in some way.
I understand that the situation is not so easy for young scientists now for many reasons if you compare to what was going on, let's say, 30 or 40 or 50 years ago. The first point is that now science is global. There is a global competition all over the world, and much more scientists now than there used to be. So by definition, the competition is harder. There is also the fact that science has developed in a global market where competition is considered to be the only value. And this makes also things difficult. And I think the situation is different according to the country in which you live, because the way scientists are being trained and hired by institutions is quite different. In France, for instance, young scientists are very early on hired on a permanent position, which is in some way good because it secures their future, but the counterpart is that they are not given many means to work. Whereas in Anglo-Saxon countries, they have a tenure track position, which means that they are not sure of their future at the beginning, but they are given money to start, they are given an environment which allows them to try to build up an independent scientific activity, and they are promoted to tenure much later if they are successful. So this is already a big difference between the different countries, and we can argue on both sides. I think it's very important for a young scientist to be able to work independently as early as possible. And for that, I think that the system in which young scientists are given the right environment at the beginning is the right one. I think there are 2 points, 2 essential concepts here for science. One is time. Science is something which develops over a long period of time. For individual scientists, it's the case. If you have an ambitious project, it can take 5 to 10 years to be developed, whereas the people who give us money are obsessed by short-term results. So they give you money only on the projects that you will deliver in 2 or 3 years from now, which is very often impossible. So you have this contradiction between the short term of time in politics and in the organization of science and the long term of science. And we have, for young scientists, we have to be able to adjust the system and to give to young scientists enough time. And the second very big concept is trust. You have to trust the scientists that you hire, because if you have chosen him or her, it means that you think that he has intrinsic value and that he will be able or she will be able to achieve. And trust is again something which is played over a long period of time. You cannot just invest your trust and ask the guy to deliver in 2 or 3 years. So trust and time are the 2 essential issues, and we have to make the political, the people who give money, the people who define the scientific policies understand that without trust and without time, nothing can be achieved. And this is a big problem here, and this is a big problem that young scientists have to face in the present world.
Yeah, to come also to your question, as Serge mentioned, the question is of course to have also freedom and finances. We have in our institute, we have junior members. They, we take them in on a worldwide selection by asking our friends around the world to give us names of good people they have had in their lab. So we selected them. But the idea is that these juniors, we help them start. They get finances at the beginning. They have total freedom. They don't depend on anybody else. From the moment they are chosen, they have to be totally free. But then they are totally responsible. You cannot have money and freedom without responsibility, which means that it is admitted that after 6 years, they have to leave our institute. Not because they are no good, but because I think otherwise the system stops functioning and they spread over the world. For instance, the first one we had was a young lady. She's now professor at Oxford. She left after a certain period. So I think I understand that one wants freedom, but if you have freedom and money, you are responsible. And then you have to take it on yourself. The question is also not everybody, of course, one would like everybody to succeed. But unfortunately, we are not equal. We have the same brain. So I think when we understand better about the brain in 100 years or so, probably everybody can be Einstein. Could well be, I don't know, it could be. After all, the molecules are the same. But of course, let's not talk about that because it's too complicated, we don't understand it. But the question is the same for all professions. For a pianist, there are very good ones, but only some come out. But there are many very good ones. My father was baker. Look, there are many bakers. Some make better bread than others. So it's in all professions we have this, and it depends on what you might call a talent, and on your work. For a pianist, the whole day, you do this all the time, you have to learn that. So I think for all of us it's the same, and nothing is guaranteed. Maybe that's also something. At some age you must have a permanent position, I would say. The society is a sort of in obligation to have these people. But still, if you work. Otherwise, we spend the money of the taxpayers, of our people in the country. So it's a responsibility. which we have, and I feel it very strongly. Also, we were talking about this thing in the car also. We have a profession which is unbelievable. We are getting paid for doing what we like. Huh? So I don't feel allowed to complain. Okay, but I agree that there are many ways in which this does not work. And there are still countries where there is a fantastic hierarchical system where there is somebody sitting on top and the other ones does work for that person. I don't think that's right. That's why the Anglo-Saxon system is, I think, good. From the moment you are assistant professor in the US, you are in principle free, but responsible. Which means that if you don't work out, you have to go. It's a bit brutal sometimes, but because if let's turn it around. If people stay in the system, which should not be there, they close the door for somebody else. So in other words, if we work for our corporation, we close the door for those who are not yet in the corporation. So that is not a just, not right, not correct.
Okay, I fully agree with what the gentleman next to me have just mentioned. I think the freedom that you have at universities and research institutes, we should value that a lot. And please take your freedom, despite the fact that governments and money, I know of course we spend public money and we have our responsibilities for sure, yes? But imagine we would not have competition. You would be very unhappy, yeah? Because I think competition in science and in education and training or whatever is a crucial aspect of the whole game. Yes, I'm strongly in favor to emphasize young people and to put your money on young people, young stars, give them freedom and make it possible that their talent can be used to the benefit of our society. But also I think we have a duty to tell our governments, to tell our taxpayers, to tell society, maybe an output in 3 years in fundamental science is not the best way to spend your money. I see now that money is spent by governments on programs, for instance, I'm a chemist, on industrial projects, related projects, that you can see that these processes will be obsolete in 15, 20 years. Is this the way to spend our research money or the education of our young people? I don't think so. I think we have responsibility to look to the future. I cannot emphasize it enough. And I think for the young talents at universities, we should give them freedom, we should give them opportunities, but they also should take that freedom. And yes, there is a competition, and that is really important to bring us forward. Having said that, I think I'm extremely optimistic, because if you look at these challenges around, where there is questions are asked to the scientific community, how are we going to fly in the future? How are we going to feed 10 billion people? How are we going to develop new drugs? Yes? Quantum computing was mentioned. How are we going to deal with ethical issues when we integrate chips in our brain? Something maybe we should start the discussions at universities and not leave it to the general public, and maybe train people to think about these things. What are we going to do? There are many, many fundamental questions with extremely important consequences for society that maybe not all our leaders are really aware of. You mentioned influencing the brains of a rat or a mouse. What will happen in the future with ourselves, you know, when we are half robots, integrated with technology, etc.? Can I zap your brain?
There are already many robots around.
Yeah. But even without robots, we are already influenced by the technologies. Look at what happened in the recent elections, where the internet has influenced the outcome. This happens. And I understand I agree with all the problems and all the fascinating issues that you are mentioning. The only word I am not sure I agree with you is I am an optimist.
I am an optimist because I'm a scientist, I tell you. And first of all, I train young people, and that gives me a lot of pleasure every day. And I'm very grateful for that. And I think we should bring the message to young people to be optimistic, because you will shape our future. That's point one. Second, there's a lot of talk about sustainability. How to build a sustainable society. I can tell you there's only one thing that's really sustainable, and that's creativity and imagination. And I see a lot of young talents here that are extremely creative and have a lot of imagination, and you will shape the future, I'm convinced of that.
I agree, you are optimistic by duty, and I agree with you about that.
Thank you very much.
Yeah, I think you are right, Serge. We have to be optimistic.
I would not say...
Even if we are, our tendency is not to be so much optimistic as you.
Oh, I have sometimes a pessimistic day
because
when I talk.
What is the other solution? The other solution is to jump into the river.
That's the only way forward. Come on, guys.
Yeah, that's optimistic by duty. That's exactly the way to put it.
That's a good one.
More questions? Yeah, Hans? Hans Gudel?
I'd like to take up a point which was mentioned. Is this?
Yeah, working, yeah.
I'd like to take up a point which was mentioned by Serge in the beginning. Honesty, credibility. I think it's very important. You said we have to boast things when we write a proposal to Brussels or to another agency. We are using buzzwords. We are talking about design. You mentioned the importance of serendipity. I think most of the big discoveries have been achieved by serendipity and not by design. And I mean, you guys are in a position, you have influence. What can you do about this? Why are the funding agencies or the committees looking at these buzzwords instead of the content of a proposal? I think this is a serious problem in science because our credibility can get lost completely.
Yes, I think it's an important issue. First of all, I think that when we write a proposal and when we boast and when we advertise in that way, the people who read the proposal know about it. It's a kind of gentleman agreement. We use this buzzword, but the people who decide for the money know very well that what we promise will not be achieved, but they know that we are going in the right direction, and that's why they give us the money. So I agree it's a dangerous game too, because inside the scientific community we might well agree about what we are just saying, but the people who deliver the money, the politicians, don't know exactly that, and after some time, if we don't deliver after 10, 15, 20 years, the field might collapse, not because it's not good, not because good science is not done, but because what we promise is not achieved. And I think this is a danger. And it's a danger in the society at large, because these values, the value of advertisement, the value of the market, the value of the global, the fact that one considers the global competition is always good, and that's the only rule, is something which I think is dangerous and wrong. I agree that the competition is good. I agree that good science can work only if it's open in the world. But I think also that some new ideas must be protected against the global competition. I will give you one example. I'm a physicist, and for many years, for the last 20 or 30 years, string theory has been the fashionable trend in theoretical physics. And most positions in the world for young people were given to string theorists. String theory is a highly mathematical theory which has not delivered what it has promised in terms of new unification of the laws of physics and so on. And one might wonder whether in a kind of Darwinian process it has not eliminated all other ideas which may have thrived if they had been protected against this global environment. So we have to find ways for science to work properly, to protect new ideas which are still fragile and has not developed against this global competition, against this need to advertise all the time. And this was not the case in the past because the physics community and the scientific community was much smaller, and people could work independently. After all, Einstein worked alone. He never asked for any grant. and his ideas were very controversial when he started. I don't mean that by just changing the rules we have a new Einstein immediately, but I think this is a very important issue. 50 years ago, when I wrote my first papers, I never asked myself, should I publish in Nature or in Science and have the cover? And I didn't even know what Nature was about. Nature was a journal for biologists and not for physicists. And 20 years ago, it has become fashionable for young physicists to publish in Nature. And we have to think about the fact that Nature is a commercial enterprise. It needs money, it needs advertisement, and so it promotes, in quite natural way, fashionable topics. And so, and this is a kind of vicious circle, and we have to ask questions about that. When in my group we get a nice result, the pressure to publish in Nature or Science comes from the young people, because they know it will be good in their CV to have such a paper, and we do not feel able to go against that. After all, we don't have our reputation is not at stake. If the young people want to publish there, we play the game, and by playing the game, we encourage it, and this is a problem.
I totally agree with that, and I think I would like to give an example. My first paper was in tetrahedron letters. Who knows what is tetrahedron letters? Oh, there's some. Oh, good. It's fine, not so bad. And in French. And the first paper of Jean-Pierre Sauvage was in tetrahedron letters in French. So you should publish.
Mine was in compte rendu de l'Académie des Sciences.
Oh, that's good. In French. Of course. You see?
Me too.
You too.
Compte rendu, no, me.
So you see,
the
pressure. I think this is really a problem, because the editors of Nature and Science, okay, in itself, the average of papers there is very good. That is no doubt. But maybe not the best ones. The ones who introduce something. Again, if I come back to 1987, Müller and Bernotz, they got a Nobel Prize in high TC physics. And they had published a paper, I think the title was something like, a possible high temperature transition. I think the title that was possible. And they started the whole thing. Physicists realized that that's a very important field, and so they influenced very much. And that was in very secondary journals. So I would say Nature and all this high impact stuff, they have on the average very good papers, no doubt about that. But maybe not the most influential ones. The other thing is that these editors there, of course it's commercial. The editors also, they make the future of young scientists. Has to be careful about that, huh? When they accept a paper. And look, in China, you get a higher salary, you get promoted and all that if you have a paper in natural science, which is terrible.
This is scandalous.
It's completely turning the system upside down.
As first author, huh?
As first author, maybe.
Honestly, if I may comment, it's not only in China, also in Europe.
No, but China is very strong. I know China well, and it's very strong there.
With all respect, when we publish a paper in a Nature journal or a Science, one of these journals, immediately the office of the university calls us, oh, what did you publish? There's some highlight. I see in our field, Journal of American Chemical Society, unquantified as the top chemistry journals. Never has any officer of the university called me when we had a top paper in JEX or unquantified. So there is also a way of how we promote, we together as university communities, you know, what we think is important. And I think this is not only in China. I know in China it's exaggerated towards your salary and all these things and promotion, but it's getting a little bit out of hand. I fully agree with you.
There is another point which was also coming out of this question. This is about letting things develop, as you said, sort of protecting, not having everything sort of going the same way. And in fact, there's a very nice sentence, but by our former colleague, François Jacob, where he's translated into English when he said, diversity, that means many things, is a way to prepare for what you have not predicted. That's diverse things, and to prepare the stage for what you have not predicted come out from somewhere. La diversité, une façon de préparer au possible.
I had recently a very interesting discussion with a journalist who the first question, as always, was, what can you apply it? What is the application? And I said, look, why don't you, I'm a scientist, why don't you ask me what new scientific discovery or new scientific insight did you get? Then he was completely silent.
This reminds me of a well-known story about American physicist Bob Wilson was a high-energy physicist who was interviewed by the senators in the United States about the building of a new accelerator at Fermi Laboratory. And the question which was asked to him by one of the senators was exactly the one the journalist said, will it be useful for the defense of the United States? And the answer was, no, sir, but it will make it worth defending. Which I think is
that's very good. That's a good one. Very good.
We have another question, yeah?
So thank you very much. I just wanted to have a comment on you on a topic that hasn't really arisen yet, which is the tech transfer. Right? We are really now as scientists being pushed to participate in the transfer of our research into the innovation, into starting SMEs, technology companies, etc. And in fact, Jean-Marie, it was very funny because 2 years ago, I think we met in Gaborone in African Material Research Society. You gave a very nice talk. And actually, I saw that some of the shelf repairing materials that you have created or you have sort of developed are being used by a company to create these hard valves, etc. And actually, the connection is very nice because it comes to here to Valencia because we produce some of our spin-off produces one of these equipment that processes your materials within this company. And it's funding actually to what the research is here to do the research. So it's very funny how the things are connected. And I just wanted you to make a comment on how important it is for scientists to really participate all the way in the tech transfer that they do.
My first comment is we should talk about together, okay? No, really, maybe we have some time to talk about. Now, for those who have not been, and thank you for listening to my lecture because I even remember it. That's pretty good. Now, the thing was the following, and this is a good example of what I use often as an example when there are people sitting in the front row who have deep pockets and a lot of money in it, to tell them how long it takes to go from basic research to applications. In 1990, we had published the first paper on what is now called supramolecular polymers. It took some time to develop, and there was fantastic contributions from a colleague of Ben, Bert Meyer in Eindhoven. So that then developed as a field in 1990. And suddenly, in 2013, 23 years later, I got a message, an email from a small company, which has a sort of it was more than a startup because it had been working for some time already, saying that they had taken some supramolecular polymer materials and developed them into first of all, reconstruction pieces for young children who had heart failure, and then made also heart valves. But that took 23 years, and it was done, and now a number of children around the world who have this correction in their heart, this reconstruction. It was done in Moscow. It's also a good example of how things work. We did that in France. We developed it for some time, but many people joined, especially in the Netherlands. I mentioned already Bert Meyer. And the startup company, the head was a French. The headquarters are in Zurich, and the company is in Eindhoven. And the operation was done in Moscow. You see, you cannot predict that. How do you know that something you did and you published in Advanced Materials at that time, 1990, and ended up in having a child, Dominica, having a child having heart reconstruction in Moscow? You cannot. And so
people have to know that, to realize that basic research gives you means which develop in many, many different ways, which are difficult to predict where it will go, but if it's new, there's a good chance that it will be applied. Something will come out of it. But you need a lot of people, and here one has to recognize also the engineers, even the people who are ready to give the money for something they don't know yet if they make money with it. This company, this small company, had first of all had somebody who knows about these materials, and this came out of the group of Bert Meyer. Then the thing was that they had to believe enough in it to set up a small company. Then somebody had to finance the company. Then they had to do all the operations first in models, then in animals, until by slow steps they come to the point where you can think about introducing it in a human. And then you have to find the surgeon who does it. Long, long way to go, especially when you deal with putting something in a human body. But it happens, and all the drugs which are now being developed, most of the drugs we are using are coming from such kind of developments. There may be a word on regulation. Something which may hinder progress in application society is also the fact that we're getting less adventurous and more afraid. We now have so many rules which control everything that maybe lots of things disappear just because there might be a danger. Aspirin would not be a drug, because aspirin is not good for your stomach, because it's an acid, so it attacks the stomach, but we use it. But nowadays, I'm not sure it would go through the regulations. And again, if you turn things around, those people, suppose you have a drug and it has a problem for 1 person in 1,000, and it's abandoned. But it was good for the 999 persons who didn't have that problem. So those could complain that that drug is not available for them. So it's a two-headed sword. You have to protect people, sure, not do anything, but on the other hand, you have also to realize that by doing too much of that, principe de précaution, as we call that, precautionary principle, that is a way to shoot in your own foot often. You don't take all the advantage, you only look at the risks. Of course, in pharmaceutical companies, the advantage-risk balance is a very important thing, but sometimes they stop just because there might be a risk. And they don't want to invest in something which after some time may be forbidden, and then they lose all their money. So it's a sort of a defense for the big companies. They get attacked. Of course, I realize, let's take glyphosate. Glyphosate. Big debate. Glyphosate is not dangerous. It just depends how you use it. And there have a lot of studies being done that it is not carcinogenic. Maybe 1 person in 1 million or in 10 million, but you don't know, you cannot make a correlation. So I think it's not science when you say that glyphosate is bad for you. The trouble is that there's a big company behind, and the big company makes money. And so many people complain, and especially on, let's say, the left side of the society, which is very respectable, but nevertheless, when a big company is involved, money is involved, and money is bad for you. It's not true. A company cannot work without money. They have to pay the salary of their people at the end of the month. So you cannot just say big companies are just crooks. They are not crooks. Of course, they are crooks. There are people in these companies, they want to make money first before looking at what are the obligations of the company against the public. That exists, no doubt. But that is also true for cars. That's true for many things. So one has to try to be reasonable and accept that companies have to make money. And unfortunately, not all companies and not all head of companies are maybe, let's say, honest people. They want to make money.
You open a big discussion here.
Yeah, I know. You can stay for some time. Yeah.
I would like to make it, I fully agree with Jean-Marie. I would like to make a few other remarks. And that is, you know, we are here at the Parc Científic, and that says already something. There are tremendous opportunities to join university groups together with industrial groups. First of all, stimulate your students to get startups when you have a good idea. And in the natural sciences, there's plenty of opportunities. Of course, there will be failures, but don't be afraid, because we should try to start new things. My students started new companies, you know, and it's a joy. It's also a very good training and a way to learn about how to get something from laboratories to a real life product, etc. It's a difficult way, but it's a beautiful challenge. But to give you another example where there are tremendous opportunities, for instance, in Holland, we started a new center, a national center for sustainable chemistry. So 3 universities, a technical University of Eindhoven, engineering school, heterogeneous, homogeneous catalysis and synthesis, joined with Shell, BASF, and AkzoNobel and Nourion, 4 big, major multinational companies. Together with the government, they sponsor it, a 10-year minimum, 10-year program to do long-term research on new catalysis, new chemical conversion for sustainable chemistry, as well as for new materials. And this is a tremendous opportunity because the companies realize that they have to come up with new opportunities, beyond the existing ones. So what will be the chemistry, the materials of the future? And this is also a fantastic stimulus for academic groups, because we have to start with fundamental questions and then look and talk with our colleagues from industry and see, oh, could this ever go to a potential application or whatever? And so for the training of the students, many of them who end up in industry anyway, it offers fantastic opportunities. So I see it also as an opportunity to train our students and to bring them forward. Of course, not everybody should play his own role. We as a university group, we are not an engineering group that develops a product to the market. That is the typical role that a company can do. They can see the ins and outs, and it's a long way, as Jean-Marie mentioned. But we should not be too afraid of that. And this offers great possibilities. I see this program now running for a year in the Netherlands, and we are now going this year to 80 PhD students and postdocs in these 3 universities, together with industry. And there are tremendous things going on. So yes, see it as an opportunity.
Let me come back to just what Serge said, that I have opened a big discussion which could last very long. And I want to put my foot in it more. We should talk about nuclear, not be afraid of nuclear. Physicists know what nuclear energy is doing. They can calculate exactly what happens. It's a technical problem. GMOs, genetically modified organisms, I'm much for it. I never buy bio stuff. I try to avoid it because, okay, maybe, but wait a minute. Vaccination, which now many people refuse, and in the US, la rougeole, what is again that rougeole?
Measles.
Measles now is coming up. And then one story, I should quickly tell you. There is a booklet, a magazine, which was published 25 years ago by the Academy of Medicine of the USA. The title is Facts versus Fears. And that discussed a number of cases where people were afraid, but where the facts did not agree with that fear. And one case, which is a very well publicized one, is DDT. Now, DDT is not good for you if you take it by the spoon, of course. And DDT is remaining in the environment, so it's not good in that respect. But the example they give, I don't remember the dates exactly, but the end of the 1950s, there were about millions of people having malaria in Sri Lanka. There was Ceylon at that time. So DDT was introduced, the mosquitoes were killed, and beginning 60s, there were, I think, 17 cases of malaria in the same place. Then the book, the big first victory of profound ecology, deep ecology, Mrs. Carson's book, Silent Spring. The little birds will not sing anymore in the spring because of DDT. That killed DDT. So DDT was forbidden. 10 years later, the number of malaria cases in Sri Lanka were the same as before DDT. And so how many people were killed by that? I think this is almost murder. Of course, DDT is not the best, but it was affordable. There were no other good substitutes. It's clear that now there are better ones, but they're more expensive, much more expensive. Now there are other ways, of course, you can do it, and now they do, but does that by putting insecticides on the linen, on the beds, and so on. Okay, that's another way, but you spread it anyway. So the question is really, are we allowed, because of our birds in the spring, to kill so many million people because of malaria? And the birds still sing. Maybe not the same way, I don't know. They've evolved, perhaps they like DDT now, I don't know. But it's really a question. We have to be very careful that things we do are maybe not so bad for us, but we can look at our neighbor, because we are in societies, we don't have these problems. We don't worry about this. There are no mosquitoes like that here. So I think it's really a very big responsibility of going the wrong way.
When I said that you are opening a big discussion, I did not think about that. I agree completely with you, with what you said. I thought you were opening a big discussion when you talked about the ethical values of the big companies, and this is different.
You're right. I have been, a chemist. People never believe a chemist, because chemistry has a lot of companies, and I have been a science advisor to many big companies. I can assure you that it's a little bit of self-correcting system. The trouble is, in earlier times, the heads of the companies were usually people from the profession, chemists for chemical companies. And now there are mostly people who look at stakeholder values, shareholder values.
Who don't think they have molecules in their body.
Exactly, you're totally right. So the only correcting factor I see that they know that if they do a mistake, it will get back to them. If they do something, it's not always self-correcting, but in most cases, they are afraid of the fact that they can be attacked later on and lose their whole job. This was also the case for the cars. They tried to get away with it by making this, by tempering the methods of measuring what is it, CO or something, or the exhaust of the cars, and now they have to pay for all that.
And it's good not to be in Japan when you have a car, when you are the head of a car company and do that science thing.
Yeah. So it's really big companies. In fact, I must say it has changed. When I was at the beginning with Rhône-Poulenc, in Rhône-Poulenc they were really mostly chemists. And they were even very trusted. They trusted their company, and the company could trust them. They would have gone through fire for their company. They believed in the company. It was their own thing. And nowadays that's not the case anymore. In most big companies, there's a big distance, and you don't do that so much anymore.
I can give you an example in physics. In the 20th century, maybe the most successful laboratory in basic science was the Bell Laboratories. And Bell Laboratories had maybe 8 or 9 Nobel Prizes in all domains in physics where had been working there. And then it was ruled by physicists, and the director of the Bell Lab has the talent to find the right people and to give them the chance to work on the topics they could choose freely. As Jean-Marie said before, it was really the rule of the Bell Labs. And when the telecommunications were deregulated in the 1980s, the Bell Lab had to compete with other companies which came on the market, and then the only value was what the stakeholder wanted. And the stakeholder did not want to spend money on basic science, and so Bell Labs disappeared. Mostly, there's still the name of Bell Labs, but it's no longer the same spirit at all. And in fact, there have been Nobel Prizes. I think a Nobel Prize was given 3 or 4 years ago for the CCD camera. And I call it a posthumous Bell Lab Nobel Prize, because it was given for research being carried out 40 years ago by a lab which does no longer exist. That's also one result of the globalization and of the triumph of the rules of the market over the rule of science.
That's also true for chemistry. There was a very big company, DuPont de Nemours, DuPont de Nemours, as they say over there, which also disappeared. DuPont had, they were the inventor, Carossus was nylon, Teflon, many things like that came out of that. In fact, the person who got the Nobel Prize the same year as myself in chemistry, Charles Peterson, was from DuPont de Nemours. And they did a lot of things. So that has also more or less now disappeared. It is linked to the fact that the central research departments, like you mentioned, disappeared. There's still a few companies, like BASF still has a central research, but DuPont doesn't have it anymore. Poulain doesn't have, doesn't exist anymore. So this aggregation, there was a fantastic physics department, like DuPont Nemours was a fantastic chemistry department.
So I agree that there should be a good connection between basic science and innovation, as was said before, but this has to be played on both sides. And I think the private companies do not invest enough in basic science, and that's a problem.
Yeah, not anymore because of money. Yeah?
But that, as I said before, I agree that gives also new opportunities, and opportunities for universities. You see this at science parks, at cooperations with industry. And I think there is also, in general in this discussion, I think there is an important duty for all of us, and that is to bring forward facts and understanding. You cannot expect, if you CEO of your company or a leading person has a university education in law school or in business school, they hardly know anything about physics, chemistry, engineering, biology, etc. Yes, we have to forward the message and make clear what are facts, what is inside. If you want to build an electric car, you cannot do it with air. You need a battery. You have to develop this kind of materials. You have to invent and discover, and you have to tell about it. The same holds for if you would want to develop an herbicide or an insecticide or whatever, or a new drug. So yes, we cannot lay back and say, oh, they are complaining about science or they don't know. We have to do it. We, ourselves, together, all of us, in education and whatever. And sometimes it is a bit frustrating. I experience it quite, and we all experience it sometimes. But we should not afraid of doing that, you know. Advocate the message, what is facts, what is fiction, yeah, what is our society based upon.
Coming just back to this question of the change in these big companies and research centers has indeed, as Ben just mentioned, given opportunities to university and young scientists, because the system has changed quite a lot. The big companies don't have much innovation anymore because they don't have the central research departments. And they need innovation. So what they do, they scout around and look at what small companies have something interesting and then buy it up. So in some respects, for all of you, that is very interesting, because if you have a good idea, you can develop a small startup, and then if it is successful and it's good for some company, they will buy it up. You make money, and either you can then lie on the beach or invest in something else. And most of those who started, they will not lie on the beach. They will invest in something else. So this has changed the way now we operate, where I have also been a co-creator of 4 or 5 companies. One is on Alzheimer's, that is now on the market. One is on an anti-cancer drug, which is now in phase 2 in Zurich. And the third one on ALS and Parkinson's. So, you know, in some respects, at the beginning I was wondering, why do I do this? That's not really what I want to do, but once you get into it, it's interesting. But you must have people who handle it. You cannot do it yourself. You have also to recognize that you need the people who make it function, because it's a lot of work. You have to get the money, you have to get the people, you have to get the labs and all this.
To fill the income tax returns.
Yeah. This is even more complicated. too much, even for a physicist, you know?
Yes.
Even for a physicist. Okay.
No, then the companies are changing a lot, as you say. Before, the companies were selling products. Well, they are still selling products, but little by little they are selling ideas, or they are, in that case, trying to find ideas and to manage, well, in that case, to manage these ideas, to distribute, to sell. Then Google and all these companies are not companies that have a real product. They have another kind of thing that are more ideas. Then from this point of view, scientists can be closer to this kind of companies, and then this is quite different from the previous state in companies. Then this is an interesting option. Well, I think that we have discussed the things that I have put here in my schedule. Then, well, you see, we have discussed about challenges in science, for example, quantum computation, and also we have discussed about the brain, the relevance to understand the brain. Well, how important is to understand the brain to develop many things, including to understand also artificial intelligence. It's necessary to understand also first our brain. Well, or perhaps it's not necessary, but little by little we are having a kind of also competition between neuromorphic computing and quantum computing is a problem that people are having, that in which, well, I don't know if you want to enter in this topic, Serge, but well, no? No, neuromorphic computing and quantum computing. People are discussing the two parts in which, well, one is related with the brain, or the way in which the brain is.
It's two very different approaches. Quantum computing has nothing to do with the brain. The brain is hot and warm and soft matter. It has nothing. It does not work according to quantum laws. Of course, the molecules in the brain obey to quantum law, but as a functioning system, it has nothing to do with quantum. And I think the artificial intelligence is more related to the functioning of the brain. It's trying to discover ways to algorithm to process information in an efficient way. The problem is that the data, it is based on the exploitation of a huge amount of data that only a computer can do. It finds sometimes solutions. The problem is that we don't understand why this solution and not another one, and that comes to a question which was asked at the beginning. What can a scientist, a researcher do which artificial intelligence cannot do? And I think the point, scientists can try to find the principles which are behind the results that the artificial intelligence is showing us, because it's the only way to be able to extrapolate this result and to find other things which might be important discoveries. I think, from what I understand, artificial intelligence is just a mean to sort and to exploit huge amount of data, but we need a brain behind that to make sense of what is observed and what has been obtained.
Mm-hmm. Okay, we have discussed well, these challenges, and also the how we are at this moment attacking the science. Then we have been discussing about the research and transfer with the companies, industry, and also with the society, and also, well, about the groups of research. We have been discussing about the nature of the group. I think that here the opinion is to have a group of the Anglo-Saxon type. You prefer this kind of group, or you prefer a group that is more multidisciplinary group in which several peoples are working in the group in a complementary way and attacking problems that can be more difficult to attack if you are alone? Then the research is a research. Well, what do you prefer? Which is the model you prefer? From this point of view, for me, it was clear that, well, some of you prefer a kind of group. Well, for example, the model that Lehn has in the institute is a model in which individuals are creating research, well, and then they are producing science in an individual way. Well, I suppose that they collaborate among them. Then the way in which that is generated is because there is some confusion always. People are thinking that to be independent means to be independent and not having relation with anyone. And then we should discuss this point, because otherwise for the young people
it doesn't mean exactly that. It doesn't mean having no contacts. First of all, our institute is small. We have only 5 juniors, which is and only 4 seniors. That is not a big thing. Now we are increasing a bit. But if the people are really very good and original, they will automatically collaborate. Not necessarily even within the institute. And they, for instance, Thomas Hermans, who was a Belgian, he is a bright young guy. He has set up a company already in his 2nd year around, and he's collaborating with many people. And right now, Thomas Eberson is collaborating with Joseph Moran about modifying catalysis by putting it between plates, coupling it with vacuum energy. That's quite an interesting field. So I think they collaborate. I think both models are fine, but it is good to maybe to help young people, independence, feeling that it's your stuff you are doing. And then you automatically, I like to collaborate. But on the same hand, it's good to collaborate among equals and not being forced to do so. So I think we like that model also because we are small and then we can have a high diversity. In fact, when we started it, the question was just any very good person in almost any field. Just good people, and they would automatically generate good stuff.
No, but the French system is a little different in general.
Yes.
Okay. I think that it's important to give to young scientists the independence and that they become what we call principal investigator. But of course, this works only if they are in the right environment and if there is a critical mass of other people working independently on similar ideas. I think the most successful research institutes in the world work along these lines. They pick up very bright people, they trust them, but they put them in the right environment, which means that they are not just the only one working in this field, in the institute. You need to have a critical mass around you. And I agree it's different from the French system for a very simple reason. Because in France, when you hire someone, you give him a permanent position, there is no way you can give him or her any money to start. So automatically, as soon as he or she is hired, he or she has to find a group to enter into, and then they cannot be independent from the start. So that's, unfortunately, that's the only way it works there. So you have labs which concentrate many very bright people, and sometimes this lab has very good results, of course, because even if it's not the ideal way to work, it works, and it has given very good results. And then the independence comes later on, when you can start to get your own research contracts, and then the independence comes later on, but I think it's not the most efficient way to do it.
I think there's somebody talking with a good example. In that place where Serge is, you had Kastler, Cointanucci, Haroche.
Yeah, Nobel Prize.
Not so bad. Yeah. And there are others somewhere around, yes. Probably. Maybe.
Hope so, yes.
You hope so. So, okay.
But I was given, I must say I was given independence.
Yeah, exactly.
At that time, it was about 30 or 40 years ago, the lab had money. They had some regular money coming into the lab. And when I wanted to start my first experiments, I did not have to apply for contracts. They did not exist. And I did not have to write any proposal until I was well into my 40s. And at that time, I was already recognized I could do it. But it was very important for me to be completely free from all bureaucratic red tapes and so on. And at that time, there were no computers, which was good also, because now I see the young scientists spend half of their time writing proposals or writing reports on their computers, and I think this is a big problem that maybe we not address enough today, that the fact that the bureaucratic requirements make the life of young scientists look more like the life of an entrepreneur than the life of a scientist. If you want to go into applied science, and if you want to start to build a startup, that's okay. But there are some young people who are not done for that, who don't like this, and who really want to do only basic science, and for them life is difficult because of all these red tapes.
I must say also, I have to say something about my thesis advisor, Guy Horisson. You don't know him, very bright chemist. You knew him, of course, he comes from your school. He was at École Normale Supérieure. And he I got my PhD with him in 1963. Then I went for 1 year to Woodward at Harvard for synthetic work. And when I came back, in France, normally, you would have been under the domination, I would say, of some guy or some lady who was higher positioned than you. But he gave me freedom. That was very important. And so I think I owe him a lot. I just said, okay, just go ahead. He hadn't much money to give me, but I could use the instruments in the lab, and so was very important. And you also said one thing, maybe that's a good thing I should say. There are three kinds of scientists. Those who all their life do their PhD work. Those who all their life do their postdoc work. And the others.
I think when you start your career as a young scientist and build your own group, this kind of freedom that was mentioned many times now is really important. And nowadays we are forced a lot, and I see this also with my young colleagues, to write grant applications and everything already. You have to predict what the outcome will be in 3 or 4 years' time or whatever. You have to, this is a fight, you know. So you cannot always avoid that, but be creative also there. And of course you can write more or less what you think you are going to do. In the meantime, be arrogant and do your thing. Be a little bit revolutionary or obstructive. Because it's really important at the beginning of your career, in my opinion, that you find your own 1 or 2 or 3 ideas that are unique and distinguishes you from your Dr. Vater, your supervisor, your postdoc advisor, whatever, that people will recognize, oh, this is her or his idea that is rather unique. It doesn't have to be big to change the whole world, but if it's yours and it's your idea and not any of us have ever thought about it or your colleagues around the world, it gives you that kind of visibility that you need. And I always tell my students, walk on 2 feet. What do I mean? Take one topic that is really original, challenging, might take you 5 years, you know, to get anything. But you cannot only rely on that, because you have to give also, because otherwise your dean will fire you, because they say no publication after 3 years, you know, what are you going to do? No grants, no invitation to give a poster presentation or a lecture or whatever at a conference. So always I advise them also to take a topic maybe which is less spectacular, but is new and decent science and gives you good papers so that you can apply for your next grant application or you get an invitation for a conference. So that's what my advice is, walk on 2 feet. But certainly come up with some ideas that are yours and give you visibility in your career. Because otherwise you're always associated with your boss, Professor Lehn, or with anybody else. And that you will never beat this gentleman. Unless you are very brilliant. But that's okay.
Come on. No, this is called bread and butter, and the other one is caviar and truffles. You never know if you want to get the caviar and truffles, but you need the bread and butter to get there.
The bread and butter is also essential because you have graduate students, and the graduate student best to get a degree in a limited amount of time. So you need to have the right topic for them too.
That is something I think we all agree, that having graduate students is an enormous responsibility, because you have in your group young brains, and it's some of the most productive years in their life. It's an enormous responsibility, this part, from starting a PhD to finishing a postdoc.
And don't be afraid.
Really makes one.
Don't be afraid. We all were students with our uncertainties, our questions. You can beat us easily. There are so many brilliant people.
I don't want to be.
Sorry. You know what I mean. I mean, you can come up with very creative, original things because the world of science is open, you know. Of course, it has nothing to do with beating, but it is this idea, when I was a young student, I still remember there were all these famous chemists that were my heroes, and I would look, oh my God, they are so clever, you know, and they did all these beautiful things. But realize you are at the beginning of your career, and you can do marvelous things that they have not thought about. And there is endless opportunity.
Then
now you pass from students to postdocs, no? You are postdocs now.
We are not.
Or others.
Yeah, that's right.
Okay, then you are in the category of others.
No, students.
Students.
We learn all the time.
We're all students.
No, we learn all the time.
Okay, then, well, we were discussing about this kind of situation, about the teams, the groups, the way in which you can do research. Well, one thing that we have not discussed is about what is important, to do excellent research or to do relevant research. Because people are obsessed also for the excellence, but not for the relevance of the work they are doing. Then they are not thinking that the work perhaps is, well, should be relevant to be recognized after, and not only excellent. Then we are obsessed for, well, in Europe, well, all the people are doing excellence. We have a magic word always that is excellence that enter in research, and this word is, well, is good, but some people that are doing things that can be considered not only excellent but relevant, I think that is also more important. No? Then this is one thing that, well, is a discussion that we can have in the next year, I suppose, about that. We have been discussing about publications. Publications, well, you enter only in the papers like Nature or Science, saying that the students who want to publish, because there is a pressure to publish in this kind of journals. Well, I remember when I was a student, was also pressure, that was a long time ago, for publishing in journals, that this is not changing too much. Then we are still, the scientists, we are playing still the games of the editorials from this point of view, and we, year by year, well, we are not changing too much this kind of situation. Then I think that, well, we are having still a strong inertia about that, and it's difficult to change. With open journals, we are having a lot of problems. Sometimes, well, with some new journal that appears, that are open journals, there are some problems that are not, because are not interesting. Well, the impact can be artificially increased. We are looking at the impact, like the television, but we are not looking at your personal impact. And now I think that the personal impact of each person is more important than the impact of the journal. Then this is an old concept, the impact of the journal that was created when it was not possible to study in a personal way the impact of each person. Now, I think that it's better to talk about impact of individual persons and try to publish in the journals you consider the best journal and not the one that is having the highest impact, because in that case you are having more visibility. The visibility is not only by the journal.
I must say that even the impact of the person can be a little bit a pervert effect,
yeah.
Because you cannot measure the quality of someone just by one number. Mm-hmm. And very often when you apply for position, the people read only the citation index of the person, not of the, of course the journal is even worse, but yeah. You have really to enter into, to read the papers and to look at the quality of the person before judging only on the impact factor. And this is again one consequence of the fact that everything is digitalized nowadays. But, I did not know what, again, if we come back to our early careers, we had no idea how many people were reading our papers. And we still have no idea now, because very often when you are quoted, you have just a quote in the paper that somebody else is writing, but I am sure he did not read the paper.
Yeah,
so it's a kind of market, you know, you are quoted, but you are not read, and the quotation is the thing which counts, and I think this was not the case long ago. And I don't want to give the feeling that I think that what was going on earlier was always better. It's not the case. I think there are very good things now, but we have to be able to resist some evolutions and to be able to be reasonable with the way we evaluate people. The evaluation of people cannot be just based on a number, on counting citation and doing things like that. And that's a difficulty, and it's...
No, but it's so easy that people are tending to do that.
It's easy because we have more and more people involved in the process, because we have more and more evaluations to do, because the system has become bigger and bigger, but we have to resist this kind of evaluation, which is not right.
Okay, then when we have
one more minute and we close the session. If you have any kind of question that you want to ask before we close today the question, we can accept it still.
Maybe connecting to this. So now we work on science, and the gap between application and the fundamental science grows. And it's more difficult to justify the finances, so the experiments become more expensive, we need more. And on the other side, we also have more students interested, learning more, so we have an army of young people wanting to work. So, and what is the vision? How do you imagine the future? How can this change in the future? Will it change, or will we fail? Or so, how do you think we should evolve as a society, the world? How should it evolve?
Not an easy question. Of course, the easiest solution is more money. But we are in a society, you need money for everything. So maybe one should try to convince our citizens that investing in science and education is really the thing to do. And maybe spending less money on other things. And this is something which happens all the time. There are many cases where you have to reshuffle, redistribute differently. It's sure that education is the most important. And especially for the developing countries, for us too, of course, for developing countries, it's very, very important. So they have to use their resources for that.
About 20 years ago in Lisbon, the European government have pledged to give 3% of the BNP in research and development. Some countries have met these figures. I think Germany is close to 3%. The countries in north of Europe, like Finland and Sweden, are doing that. And outside Europe, a country like South Korea is giving more than 4% of its budget in research and development, and Israel too. So there are examples of countries which have understood that. In France, we are below this figure. I think the total investment in R&D is 2.2 or 2.3%.
In Spain, 1.3.
Yeah. And I
have a good way to go. That's nice.
And I am in a committee in South America, in Colombia, which has been asked to find the ways to develop research. There it's 0.3% of a very low budget. So you have to convince the government that investing in R&D is investing in the future and investing in the only resource that many countries have. We don't have oil, we don't have any minerals in France or in Spain. We just rely on the minds of young people, and we have to invest in that, not only in R&D, but also, of course also in general education. And another problem that we did not address, and which is very worrying, I don't know how it is in Spain, is the fact that the general education level, especially in sciences, has going down in France. All the PISA tests are showing that the level of just simple calculation or simple reading skills have decreased, and this is a big issue. And before trying to make people aware of the values of science, of the scientific reasoning and so on, they have to know how to count and how to understand the written text. And this is something which has to be understood also by the government. And a question about science also, which we addressed. I think one of the main issues, which was already mentioned, the fact that teachers in elementary schools have mostly been raised in humanities. They know about literature, they know about history, but they are very uncomfortable about science. And if you are uncomfortable about science, you cannot teach science well to young students. Even if what you want to teach is very simple, you have to know much more than what you teach, of course. And this is a big problem too.
So if you realize that in our future, if we look at Europe, okay, stay to Europe, many of the big questions that people think about, sustainability, climate change, health, aging, food, a lot of these things are directly related to natural sciences one way or another, you know? And the lack of understanding in many parts of society, and in education is a bit shocking, you know, and you see this from elementary schools onwards. This is why I was mentioning teachers. We have to do more, much more than we do now, I think, and help our young people to learn facts, to learn insights, to be critical, to think about this. And I think this is a big challenge. There's a lot of talk about challenges in Europe, yeah? This is one of the biggest, maybe the biggest challenge. And when you look at China, where they massively invest in education, in technology, in science and whatever, I think Europe should be aware that we have to do more, yeah, if we want to stay at the frontier.
Yeah, it's true for science, but also to have an informed citizen who makes the right choice, not only in science, but in all other issues. I think there is a very interesting sentence which was pronounced by one very known figure that you find out who is he, a candidate for election in the United States, said in 2016, "I love uneducated people." So you see, I love uneducated people. So uneducated people can elect anybody to any kind of position, and we see what's going on after that. That's very important too.
Okay, then I think that with that we can also conclude. Well, there is some sentences that have been of interest here. For example, science is always open for unpredictable. It's one of the things that has been explained here. Plenty of surprises, fascinating, then to attract people. Also uncertain. You have a lot of uncertainty in science. And also, well, one important message that has also been transmitted is that the goal of a university, the main goal, is to develop basic science, not to try to, well, to do only, to go for the applications. It's basic science, the topics, and also the applications will be involved at the end, but as a consequence, not as a goal. The goal is not to develop applications, the goal is to develop basic science, and the applications will appear in a natural way in this context. Then I think that, well, with that we can conclude this year. If you have some comments.
Just one thing about this question of also developing countries that have not been mentioned. And science can provide solutions which makes things easier also for those who have not reached the same stage. What I mean by that is, for instance, the following. If you are sitting under a tent in the Sahara, 50 years ago, if you had some sickness, you could have no resources. Now you can have a phone and call a physician somewhere else. In other words, the high-level discoveries in developing countries, which were, of course, privileged compared to the people sitting under a tent in the Sahara. Nevertheless, they can be very useful for those in Sahara. So we have to transfer almost for free this thing, that the success of some can make can be of benefit for many, many people. So if developed countries like us, we have the possibility, we are living in good conditions, we have a good climate, we have a lot of things like that, but then we have some responsibility, and what we develop, what we do as basic and as application, applications of course for that the most important, can be of very great benefit for people who are not at that stage. And so these countries in Africa, for instance, they will not, most of them, many people will not have to go through the period where you had wires with telephone wires, because you go through your cell phone. So this is something which is a jump. I call that a shunt. It's shunting a whole period. You just jump over. And this is something we can do. Like drugs, it's the same thing for drugs, because they have not the possibility to make the drugs, but we can give them. That happened with HIV, for instance. HIV is very prevalent in many countries in Africa, but the drugs are now available, but you have to make them available cheap. And this is something which we can bring to the countries which need it. I think the fact that you having, of course, we would all like equality, everybody same things. This is just not possible, it's utopic. So we have to realize that if in some regions of the world it is possible to develop high-level science, high-level applications, they are beneficial for everybody. Or at least they can be if you are really kind to the others.
Okay, then I would like to conclude by thanking our three Nobel Prizes because of they are very generous to be here with us, spending the morning discussing with us about science in general, and also, well, they are very enthusiastic, as you can see. Then everybody is staying here until the end. That means that people are enjoying this kind of discussion. If you want to continue the discussion, this afternoon at 4:30 there is a discussion about the Brexit. The Brexit explained by in science. Brexit and science.
I'm a European.
Brexit and science, that will be done in the Westin Hotel, where they are now living these days for the prizes of Jaume I. But well, in any case, you can this afternoon, if some of you is interested in going there, you are invited to go. Well, especially the students will be there this afternoon discussing also about this topic. Also of interest. Then, thank you very much. Loles, you want to say something?
No, just to thank you three.
And thank you very much to all of you for attending this animated discussion. Then, thank you very much.